My name is Maria Carmel Banan, a student of City Global College, and I'm your instructor for today. I will be discussing the topic about transmission media. So first, let's define transmission media. The transmission media is nothing but the physical media over which communication takes place in computer networks. The purpose of the transmission media is to transport a raw bit stream from one machine to another. Various physical media can be used for the actual transmission. Media are roughly grouped into guided media, such as copper wire and fiber optics, and unguided media, such as radio and lasers through the air. So for today's video, I will be showing you the different transmission media. So let's start from the oldest and still most common transmission medium, which is the twisted pair cable. A twisted pair cable is made of two plastic insulated copper wires twisted together to form a single media. Out of these two wires, only one carries actual signal and another is used for ground reference. The twists between wires are helpful in reducing noise, or electromagnetic interference and crosstalk. The most common application of the twisted pair cable is the telephone system. Nearly all telephones are connected to the telephone company office via twisted pair cable, because twisted pairs can run several kilometers without amplification. But for longer distances, repeaters are needed. So there are two types of twisted pair cables, which is the STP, or the shielded twisted pair, and the UTP, which is the unshielded twisted pair. Let's start with the STP. So STP cables comes with twisted wire pair covered in metal foil. This makes it more indifferent to noise and crosstalk, while UTP has 7 categories, each suitable for specific use. In computer networks, Cat5, Cat5e, and Cat6 cables are mostly used. UTP cables are connected by RJ45 connectors. The second transmission media on the list is the coaxial cable. So coaxial cable has two wires of copper. The core wire lies in the center and it is made of solid conductor. The core is enclosed in an insulating sheath. The second wire is wrapped around over the sheath, and the two in turn encased by insulator sheath. This is all covered by plastic cover. Because of its structure, the coax cable is capable of carrying high-frequency signals than that of twisted pair cable. The wrap structure provided a good shield against noise and crosstalk. Coaxial cable provide high bandwidth rates of up to 450 Mbps. There are three categories of coax cables, namely RG59, or the cable TV, RG58, the thin Ethernet, and the RG11, or the thick Ethernet. RG stands for Radio Government. Cables are connected using BNC connector and BNC-T. BNC terminator is used to terminate the wire at the far ends. Power line. So power line communication, or PLC, is layer 1 physical layer technology which uses power cables to transmit data signals. In PLC, modulated data is sent over the cables. The receiver on the other end demodulates and interprets the data. Because power lines are widely deployed, PLC can make all power devices controlled and monitored. PLC works in half duplex. So there are two types of PLC, which is the narrowband PLC and the broadband PLC. So narrowband PLC provides lower data rates up to 100 of kbps, as they work at lower frequencies or 3 to 5,000 kHz. They can be spread over several kilometers. Broadband PLC provides higher data rates up to 100 of Mbps and works at higher frequencies or 1.8 to 250 MHz. They cannot be as much as extended as narrowband PLC. So fiber optic works on the properties of light. When light ray hits at a critical angle, it tends to refract of 90 degrees. This property has been used in fiber optic. The core of fiber optic cable is made of quality glass or plastic. From one end of it, light is emitted, it travels through it, and at the other end, light detector detects light stream and converts it to electric data. Fiber optic provides the highest mode of speed. It comes in two modes. One is single mode fiber and second is multi-mode fiber. Single mode fiber can carry a single ray of light, whereas multi-mode is capable of carrying multiple beams of light. So, fiber optics can be used for local area networks as well as for long-haul transmission, although tapping on grid is more complex than connecting to an internet. One way around the problem is to realize that a ring network is really just a collection of point-to-point links. Next in list is the wireless transmission. So our age has given rise to information junkies, people who need to be online all the time. For these mobile users, twisted pair co-ops and fiber optics are of no use. They need to get their hits of data for their laptop, notebook, shirt pocket, laptop, or wristwatch computers without being tethered to the terrestrial communication infrastructure. For these users, wireless communication is the answer. So wireless transmission is a form of unguided media. Wireless communication involves no physical link established between two or more devices communicating wirelessly. Wireless signals are spread over in the air and are received and interpreted by appropriate antennas. When an antenna is attached to the electrical circuit of a computer or wireless device, it converts the digital data into wireless signals and spread all over within its frequency range. The receptor on the other end receives these signals and converts them back to digital data. A little part of electromagnetic spectrum can be used for wireless transmission. Moving on to radio transmission. Radio frequency is easier to generate, and because of its large wavelength, it can penetrate through walls and structures alike. Radio waves can have wavelength from 1 mm to 100,000 km and have frequency ranging from 3 Hz or extremely low frequency to 300 GHz or extremely high frequency. Radio frequencies are subdivided into 6 bands. Radio waves at lower frequencies can travel through walls, whereas higher radio frequencies can travel in straight line and bounce back. The power of low frequency waves decreases sharply as they cover long distance. High frequency radio waves have more power. Lower frequencies such as very low frequencies, and middle frequencies bands can travel on the ground up to 1,000 kilometers over the Earth's surface. So radio waves also are omnidirectional, meaning that they travel in all directions from the source, so that the transmitter and receiver do not have to be carefully aligned physically. So, radio transmission of high frequencies are prone to be absorbed by rain and other obstacles. They use ionosphere of Earth's atmosphere. High frequency radio waves such as high frequency and very high frequency bands are spread upwards. When they reach ionosphere, they are refracted back to the Earth. Under certain atmospheric conditions, the signals may bounce several times. Next is electromagnetic waves. Electromagnetic waves above 100 MHz tend to travel in a straight line, and signals over them can be sent by beaming those waves towards one particular station. Because microwaves travels in straight lines, both sender and receiver must be aligned to be strictly in line of sight. Microwaves can have wavelength ranging from 1 mm to 1 meter and frequency ranging from 300 MHz to 300 GHz. So, according to the picture, microwave antennas concentrate the waves, making a beam of it. As shown in picture, multiple antennas can be aligned to reach further microwaves of higher frequencies and do not penetrate wall-like obstacles. Microwave transmission depends highly upon the weather conditions and the frequency it is using. Next is the microwave. So microwave system uses very high frequency radio signals to transmit data through space. The transmitter and receiver of a microwave system should be in line of sight because the radio signal cannot bend. With microwave, very long distance transmission is not possible. In order to overcome the problem of line of sight and power amplification of weak signal, repeaters are used at intervals of 25 to 30 kilometers between the transmitting and receiving ends. So microwave transmission, unlike radio waves at lower frequencies, microwaves do not pass through buildings well. So last is the communication satellite. A communication satellite is a microwave relay station placed in outer space. In satellite communication, microwave signal is transmitted from a transmitter on Earth to the satellite at space. The satellite amplifies the weak signal and transmits it back to the receiver. The main advantage of satellite communication is that it is a single microwave relay station visible from any point of a larger area. In microwave, the data transmission rate is 16 gigabits per second. They are most likely used to link big metropolitan cities. So this is the end of our video. Thank you for watching. And as for reference for our next video, please follow and keep watching.